And I invite De Rosa Alberto in presenting a paper, miniature recorder embedded in radio transmitters, how to elucidate behaviors and information monitoring practices in New Zealand endemic pilot bird. So, Alberto, you are? Okay, fantastic.
All right. Sorry, got a little bit of trouble with the unmuting there. Yeah. Thank you. Good day. Kia ora from Aotearoa, New Zealand. Buongiorno. Thank you so very much for this opportunity and for organizing this wonderful conference and for giving me the chance to talk a little bit about the acoustic work we do down here, as been noted before, mostly conservation oriented. Speaking of which, I also think it's always good to put things into context and remember why we do things. We do conservation because from one hand, at least this is my perspective, we have the romantic view that it's the right thing to do, and I personally believe so. From the other hand, we have the responsibility of doing so as it is crucial for the continuation of our species, just simple as that. We do conservation and we need means to monitor the conservation efforts are positive. They actually have positive effects, or at least the desired effects on the environments that we are caring for. And traditionally, some of the most common methods have been very energy intense, invasive, and have needed a lot of field work and manpower, or people power, let's call it, because that's not just going into the field, it's analyzing, it's a lot of data. And being this an acoustic conference, we have a quite good idea that sound can give us a wealth of information about many different systems. We specifically work with sound and birds down here, which are very dear to us. And we know very well altogether that sound can give us a very good idea about diversity, species richness, and we just heard about many different opportunities in which this is very important. However, many times in conservation, what we need can vary. And sometimes, for example, in monitoring a population trend or after a translocation on whether when we are deciding whether to translocate from a population or not, we need to know how many birds, or forgive me for talking about birds, what I'm talking about is going to be applicable to many systems. We need to have an idea of the numbers. To make it as simple as I can, we imagine an environment in which we have no idea of the number of birds that are there, and we can hear a certain number of vocalizations. It would help if we could identify them individually, although let's not assume that a priori. But from the number of vocalizations that we can listen to, how do we get to the total number of birds? This poses two important questions. One is the possibility of individual identification of animals, which is being demonstrated possibly in many taxa. And the other one is the identification on a, let's call it a multiplying factor from a number of vocalization to a number of birds, or a proxy for it. Basically, we want to know whether birds in a sparsely populated environment are as vocal or more or less than birds in a crowded environment. Fish were just a very good example and very visual. Now, we work with a very iconic species down here, which is kiwi, Arcteryx mantelli, the North Island brown specifically, and it's quite a good system to work with for two very reasons. It's a very vocal species. There's very diverse vocalizations between male and female. It's quite important in the ecosystem, especially thinking about the fact we have no native mammals down here. So it solves very important ecological functions. And the Department of Conservation down here actually employs acoustic surveys that are called Kiwi call counts. We can imagine them as a specialized or particular version of point counts, where few or some human observers still do point count observations for 2 hours at designated spots, and they note estimated direction of arrivals, distances, sex, and time of the vocalizations heard. Just to give you a rough idea, the male kiwi vocalizes a series of medium, let's say around 4 kilohertz pitched whistles, while the female has a fairly lower and guttural signature call, let's say, or vocalization. We have some knowledge about their call or call rate or vocal behavior, yet not enough to get to a point where we can estimate numbers or get an idea of their vocal activity over time. So to get to what we have worked on so far, we have worked with Kiwi Track Limited, which is a company that makes Kiwi transmitters. And we found a small enough recording unit, which is even smaller and lighter than the audio moth that many of you, the micro moth, forgive me, that many of you will know. This miniature recorder allowed us to build Kiwi transmitters that are still within the weight limit for Kiwi and North Island brown still, and they are basically below 21 grams each. In order to be able to do this, we went through a very intense and rigorous trial. And basically, we first took the little recorder outside of its case, and we used playback. Let me just zoom in for a second. I know it's pixelated. I'm very sorry about it. But this part on the top right side is the electronic board of the recorder with its little SD card, and on the bottom left we have the external microphone, and we use playback at increasingly bigger distances to find out a possible voice activation threshold to use with these recorders. Although at the end we couldn't really rely on that, as being the transmitters equipped on the leg of the bird, the vibrations from walking and browsing are way louder than any vocalization to begin with, which still resulted in a very interesting opportunity to study bird activity, not just by the vocalizations, but also by the frequency of its steps and the activities in its surroundings. We just heard about what would be like to hear like a kiwi, not like a kiwi, like an animal. We cannot say that you would hear like a kiwi with a recording from this, but you would definitely hear like a kiwi with human ears, if you will. Apart from working on the threshold and the acoustic threshold for the recorder, we worked on the protection for the external microphone, which is waterproof to start with, yet needed some protection. Now, we finally managed to have our recorders, and we actually applied, we had a trial run last year for 4 nights on an island where we have a 17 years old study site. The island is the island of Ponui in the Auckland region, and we specifically worked in 2 gullies. In the pink overlay, the gully is called Kauri Bush. Not that it's too relevant, but it's easier to remember. And the other one is called Red Stony Hill Gully in the yellow overlay. The red dots represent the locations of the acoustic recording units that we use to compare the individual vocal activity to the community level. These 2 gullies are both close to paddocks, and they are close to, they have swamps in them where the birds can and often do go to forage. Now, in the field, you can see that the micro recorder transmitter represent as well quite bulkier alternative to the regular transmitter. However, it does stay only for a few days on the bird. And with the help of all the authors, we managed to trial and successfully test these micro recorders. You can see all of us here. There is Stephen on the top left, me and Isabel in the bottom left, and Daryl in the middle, together with Kayla and Virginia helping us in the field. And with the extraction of the micro SD at the very end, we get to the final data. As you can see, the data that we get from the micro recorders that here I'm showing using Avians, which is the program open source, I should add, that's maintained and developed and designed by our research group, specifically born out of the programming skills of the Wellington part of the team that you will hear of later on. And if you compare the number of harmonics and the clarity or contrast of vocalization of syllables in the top spectrum compared to the bottom ones, you can see that on the top we have a microrecorder spectrogram followed by increasingly distant acoustic recording units, environmental recorders. So what did we get from this trial run? What can we get using these recording devices? Well, from the 4 nights that we had them out, we got a total of 196 recordings, vocalizations from acoustic recording units compared to 37 from the micro recorders. What's very interesting to me is the sex ratio in the recordings. Now, from the acoustic recording units, although different, male and female are still in the same order of magnitude. Whereas in the micro recorder, there is a quite bigger number of male vocalizations. This has no inferential power whatsoever. It's a trial run, but it gives you an idea of what we can get using these little devices. I would also like to add that the number of vocalizations among the birds were quite different. There were birds that basically stayed silent for the whole time, and there were birds that up to 8 vocalizations throughout the study, and that the micro recorders, like something around 40% of the vocalizations we got from the micro recorders were outside of the acoustic recording units range, which means basically that the birds went out of the gully and vocalized there to then go back. We know that they went back, and we also know the real number of birds in the gully because we also used the help of a Kiwi dog, mentioned later, to sweep the gully and find all the birds. So we have an idea of how many birds physically were there. And this is what I was talking about the number of vocalizations. To give you an idea, just to remind you of the deployment of the acoustic recording units, 3 of them failed. So you're going to see the results from the remaining 6, which are right here. So on the y-axis, you have the different recording units, and on the x-axis, those are single vocalizations sorted by time. Basically, the bulk of the vocalizations were recorded by the central recorder, and the rest, not really evenly, but distributed among the others. In the south and southwestern, I should remind you, swamp is there. They forage in that area. So it's an interesting factor. And finally, the real result we were looking for, how did the micro recorders fare about versus the number of vocalization from the ARUs? Basically, the starting point to get that multiplying factor we really would like to get to. This is, again, not of any inferential value, but it's our starting point. And we believe that this technology can actually be very helpful to get to a real estimate of population densities using bird vocalizations. Possible application of these devices are not limited to birds and not limited to New Zealand. Any animal that can carry something around the weight of 20 grams, including VHF transmitter and acoustic recorder, can carry this. And as I was hinting at before, you can get a very good idea of the activity of the animal close by the vocalization. In this case, we can see that there was quite a bit of turmoil before the vocalization. There was a little bit of a rush, of a run, and then the bird stopped and vocalized. To conclude, I would really like to thank my collaborators and supervisors, Daryl, Isabel, and Stephen, and acknowledge all the Kaitiaki and field workers that really made this possible, together with the Punaha Matatini, Kiwis for Kiwi, and Birds New Zealand for the financial support. Now, I hope you liked what I had to say, and I would be very happy to discuss any comment or question you would have. Thank you.
Thank you very much, Alberto, for this interesting communication about a so impressive animal that you handle. So, well, I open for discussion. There are some questions about this presentation. I have a comment. So the vocalization of the animals, of these birds, when are moving, create problems with recording, or what happens when we are in movements?
They usually stop to vocalize, and then sometimes you can actually see in the spectrum and hear from the miniature recorders that they adjust mid-vocalization to project their vocalization better. There are even some videos showing that they really stop during a run. They can stop during a run or something and really stand up and vocalize to really reach farther distances. That's my interpretation, but it's what it seems like.
And so I think that when the birds are in movements, they produce some noise. And
oh, yes.
Have you evaluated such additional information from, or maybe in the future?
Oh yeah, that is exactly something that we really are looking forward to, is get a very good idea of the bird activity, not just by its vocalizations, but also by the frequency of its steps and the sounds of its browsing, because kiwi being insectivores, they probe the ground and browse in the understory, and they make some peculiar noises, and not just when foraging. There are some other noises that I witnessed that are interesting for, let's say, the mating season.
Okay. Okay. Thank you very much.